to everyone, wherever you're joining from. My name is Kevin Chege, and I'll give you a brief background of the MIRA project, which will set the tone for the rest of the presentation. So the project is called Internet Resilience, and one of the things we needed to do in order to get going with the project was to come up with a definition for internet resilience that we could use for the project. And the definition we came up with was that internet resilience is the ability to provide and maintain an acceptable level of service in the face of faults and challenges. So with that definition in mind, what is Africa's internet resilience? So for many in the African region, we are probably familiar with service degradations or poor service or up and down connectivity when we are trying to get online. And what the Internet Resilience Project is trying to find out is what exactly are the causes of this, what is Africa's internet resilience, and what are the different experiences in the African continent for different internet users. Africa is a very big place, large continent, 55 countries, and there are different experiences for different people, depending from where they're connecting from. And it was one of the main goals of this project to find out what exactly that is. So we partnered with AFRINIC, and we came up with this project called Measuring Internet Resilience in Africa with two main objectives. The first one is to determine the level of internet resilience in select countries by measuring certain metrics, using scalable methods to measure internet resilience, and then aggregate this information on these countries. And then secondly was to present this information in a very easy to understand manner, whether you're a policymaker, tech engineer, or an internet user. So the two main goals are find out the internet resilience in African countries, and then secondly, present that in a very easy to understand manner. So the MIRA team, the team that came up with the methodology and the research approach that we are using in this project, the names you see here, there's myself and my colleague, Amreesh Phokeer from AFRINIC. We also have Dr. Ahmed El-Mokashfi from Simula, Dr. Josiah Chavula from UCT, who's also going to make a presentation later in this webinar, and Dr. Hassan from CMU Africa, who all helped to shape the research and methodology approach that we're using in this project. We've also been helped by several students who've done a lot of work to help us aggregate a number of data sources that are present right now. More of this will be presented by my colleague Amreesh. And I'll be speaking later about the MIRA pods, or the active devices that we're using to measure or carry out different measurements in the African region. I'm assisted by Didon Muganga, who's a master's student based in South Africa, and Henok Sise, who's an ISO consultant who's based in Ethiopia. And also a very big thanks to the MLab team. There'll be a presentation from the MLab staff or representative later at this call. His name is Chris. MLab have really helped us to shape how we can carry out the measurements using their software. So I'll close and say this is the plan for today's webinar. Arthur is going to speak next from AFRINIC, and then Dr. Chavula, and then Amreesh, myself, and Chris. And I'd like to hand over to Arthur right now to make the next part of the presentation.
Thank you very much, Kevin. And good morning or good afternoon to each of you, wherever you are. So it is a real pleasure for me to attend this webinar. So I will share with you my screen, my presentation. Okay. Do you see my screen now?
Yes.
Okay, thank you very much. So my name is Arthur Karandal. I'm the head of Stakeholder engagement at AFRINIC. Let me give you a quick view of what AFRINIC is doing. AFRINIC is the African Internet Registry incepted in 2005. And we are based in Mauritius. We are serving the African region, including the Indian Ocean. And we are serving also more than 1,009 organizations, members in Africa. And we are also providing internet registry function, allocating distribution of IPv4, IPv6, and S numbers. Okay, we also provide some outreach, and we are collaborating with many organizations such as ISOC and many others on a different initiative for leverage the level of internet in Africa. So let's talk quickly about the collaboration between AFRINIC and ISOC Africa. So ISOC and AFRINIC has been working closely over the past years to increase internet connectivities and building capacity on the continent. But last year, okay, the two institutions concluded a joint agreement to work on some projects, such as research and internet measurement, among others. So what we are doing right now in terms of MIRA is a part of the agreement AFRINIC and ISOC signed last year. So what exactly MIRA means for AFRINIC and for our different partners, stakeholders? MIRA, as already mentioned by Kevin, is a project, a joint project, okay, between our both organizations, with the goal to evaluate, okay, the capability of different countries in Africa to provide, okay, real, okay, and real means, okay, of internet connectivities to all times, because this is something that we saw the lack of ability for our government and the regulators, okay, to assess the quality of internet in the countries. So the MIRA has a very clear scope of work. We consist in collecting, analyzing data to determine, okay, the current level of the internet resilience in African countries. That is one thing is to help, okay, different countries to develop internet measurement infrastructures by increasing the number of what we call MIRA ports, okay, that are actively installed in Africa. MIRA also will help to visualize the data for users at all levels, okay, be it policymakers or engineers, network operators, decision makers, internet users. And what is really MIRA means in terms of opportunity for African regulators and government. You know, during my engagement with government, one thing is recurrent is the needs to carry out performance measurement for ICT sectors, because they need to formulate some policies. Unfortunately, there is a really lack of quality of services measurement in terms of internet access in the continent. So MIRA is something very interesting and important right now to address such a need. Why? Because that will help the government to track the evolution of internet resiliences in the country. They can have also live data to understand whether the customers are getting the service they're actually paying for. And one thing that's very interesting here also is to give the opportunity for decision makers, okay, to have accurate information, because most of the data in Africa or on the continent are provided elsewhere from some simulation, but it's really difficult to have accurate information. So MIRA will address that aspect. We can have now information produced on the continent to help decision makers on the continent. That is a very interesting thing. So how AFRINIC will support ISOC on this project? AFRINIC will provide ISOC Africa, okay, technical and logistical support. We are also providing access, okay, to different forums we are organizing, such as African Internet Summit, or when we are conducting some outreach toward our technical community. ISOC will be present to showcase MIRA. Also, we have some project that we are having with the government and some regulators concerning internet measurement. So that will be opportunity for ISOC to address that aspect of internet measurement. We as at AFRINIC, we don't have the skills for. So this is where we are going to collaborate. So we are really keen to move forward with MIRA. That's the reason we are conjugating MIRA as a verb now. Let us MIRA now. Why? Because we need ISOC to take African internet at the next level. And we encourage all the different partners to join hands on that project so that we can really accelerate boosting the digital transformation on the continent. Thank you very much for your attention. I give the floor back to Susannah.
Thank you very much, Ato. So next speaker is Josiah Chavula, but we're going to do a quick poll before we move into his presentation. We want to find out a little bit more about your internet experience wherever you are. So Amreesh, would you like to start the poll? So we have 5 questions here. Where do you connect to the internet most of the time? What technology do you use to connect to the internet? What do you use the internet for most of the time? Do you often experience downtime? Do you often experience a degraded service? So if you can all see that poll, we'll just give it another 30 seconds. Okay, has everybody had a chance to do that? We'll end the poll now. So as we can see, the first question, most people connect to the internet from home most of the time. And the technology that most people use is fiber. And most people use the internet for video streaming and not work. That's good. Do you often experience downtime? Yes, occasionally is the main answer there. And do you often experience a degraded service? Most people do occasionally. Okay. We will move on now to Dr. Josiah Chavula. He's going to give an overview of the MIRA project. Over to you, Josiah.
Thank you so much, Susan, and thank you to ISOC and AFRINIC for organizing this. I'm really excited to be part of this MIRA project, and of course to be here on this webinar to share what we are doing with regards to the MIRA study And I'm also very happy that we started with that poll of trying to find out how people connect to the internet, and more importantly, how often they experience degraded service or loss of service, because that's what we want also to be able to measure or establish as part of this project. It's not unusual for us to hear that a whole African country or a whole region is offline because maybe a single fiber optic cable has been cut somewhere, be it an undersea cable or terrestrial cable. A single cut results in a significant outage of internet, and that speaks to the question of resilience. Like, how resilient are we to withstand such occurrences when there's a problem somewhere? Do we lose the internet completely for the whole region, for the whole country, or for the whole ISP, and so on? So these are some of the things that are quite interesting for us. We want to study these and see how countries rank or rate themselves in terms of being resilient to such scenarios. So I've just to say I'm from the University of Cape Town, but I've had my part of my career in AFRINIC for a moment. So I'm quite glad that I'm continuing to work with ISOC and AFRINIC on this project. So just as an overview to sort of contextualize for those that are probably new to this, we are mostly interested in country level internet resilience. How each country stands when we talk of the resilience. And my colleague Amreesh later on is going to talk a little bit more about how we come up with the metric and how we look at the specific variables that constitute that resilience index or resilience metric. But we're going to look at each country, and then we're going to look within that country the resilience of ISPs, or the resilience of each ISP. If we could get that value somehow, that would be very important. The critical infrastructure resilience in a country, so looking at things like power systems or fiber optic cable systems and so on. So we'll look at that, and I'm going to discuss a bit about that. And then market resilience as well. There's a bit of noise coming from outside, so my apologies. They seem to be doing some service outside at the time when I'm supposed to be speaking. So apologies for that. Okay, so this work, we've divided it into a number of work packages as a way of managing the work and also collaborating. So as Kevin mentioned earlier on, we are working with, of course, with AFRINIC and ISOC, but myself, I'm in the University of Cape Town, working with my colleagues from Simula Lab, as well as Carnegie Mellon University, Africa. So we've divided this work into 7 work packages. I'll talk a little bit about maybe 4 work packages. The first work package, I will let Kevin talk a little bit more about, but maybe just to mention what it is in the context of what I'm going to be saying here. The first work package is where we are looking at the initial deployment of the measurement infrastructure. So we are deploying what we are referring to as MIRA pods. So these are Raspberry Pi devices where we are able to run our measurement tools, our measurement scripts, and so on. Okay, so the deployment of these devices into different countries, different networks, is the work that we're doing now, and Kevin is going to talk about it a little bit more later. And then work package number 2 is where we developing the framework for coming up with the resilience index. So this looks into getting the initial data sets, the metrics, and looking at how to combine them to come up with a composite value that we would call the index. Of course, the framework would allow us to combine those metrics in different ways to see how they impact the actual index. But I'll let Amreesh discuss that in a little bit more detail again later on. Okay, and then another work package that I'll not maybe dwell too much on is the last work package number 7, which is sort of going to be the final or end product that most people are going to interface with. And this is where we're going to have a dashboard with the results or the data, allowing people to interact or explore the data sets, as well as provision of an API that would allow others to also use this data set for other applications. So again, I will let Kevin talk about what we've done so far in this regard. Okay, so I'll focus more on the other work packages to give you a view of what we're doing. Okay, so work package 1 is what I just said. This is the MIRA pod. It's a Raspberry Pi device, very lightweight. Maybe one of the questions that people might be thinking about is why are you deploying your own infrastructure when there are already quite a number of measurement platforms that you could be using? So maybe one of the things that we thought about was the kind of independence and flexibility that we need. We want to be able to have an infrastructure that we can build new measurements on. We can, think about the specific types of measurements and measurement campaigns that we need in Africa for the kind of resilience objectives that we are looking for. And we thought that we needed to have something that we can manage, we can control, we can build upon. And of course, it's lightweight, so we hope that it does not use too much power in our volunteers' homes where these are being hosted. And of course, we are leveraging, we're using some of the existing tools already to support these, the deployment. And I think Chris will talk a bit about the MLab tools, the Maracamo and NDT clients that some of them we're using with these MIRA pods. And then we are managing that, the platform, the MIRA pods that are distributed in all different places. We're managing them using a cloud platform, which is called the Balena cloud platform. And this allows us to create new measurements, deploy them into these pods quite easily. And this is quite useful for our purposes. And then, of course, we've got a data pipeline that allows us to get the data live straight from the pods into our data store. And we're using BigQuery for now. Okay, but we will have further discussion around this. And then we have work package number 3, which is the, for me, one of the really useful things that we want to study for diversity or resilience of our networks. And we are looking at the path diversity in doing this resilience analytics. We're looking at, first of all, path diversity. And we're looking at this from at least in 2 or 3 stages. So first of all, we're looking at the physical infrastructure, the physical paths, the physical routes that our internet use. So looking at the fiber cable systems, the landing stations, and the internet exchange points where they're located. So we are doing a sort of a mapping and sort of geo, locating the where the fiber systems, where the fiber cables run, and trying to come up with some metrics for countries to say how many cables are passing through, what is the diversity, how many landing points are available to a country or between countries, how many IXPs are in a country or available to a country, and so on. So that allows us to understand the diversity of physical routes that would be available to a country or to a region. And then we're going to take that data set and sort of map it with the logical topology. So when we talk of logical topology, we're looking at the actual interconnections between ISPs or ASNs. Different networks connect to each other and exchange traffic. So the exchange, that exchange would be what we'd call a logical link between those ISPs. So we want to understand how various ISPs are interconnected, how many or what is the diversity of logical links between ISPs within a country and between countries. And then if we can map that to the physical topology to understand what is the ultimately, what is the diversity of paths between ISPs and between countries. So if, for example, if all ISPs in one country or in a country are using the same cable system or the same path, the same physical path out of that country, then if that single physical path is disrupted, then all of them could be offline. So that even though they might be peering with several other connections, but if they're using one single path, then there might be a weak resilience in that regard. So that's something that we will try and map and see if there's a way to quantify or map that. And of course, we're also looking at the aspect of the choke point potential. So what is the or looking at maybe more simply, the number of upstream providers that become available to an ISP. So if all ISPs in a country use the same provider upstream or to get out of that country or to have global connectivity, then they're all depending on the same provider. And if that single provider is off, they all are out. And that dependency also creates, problems if that ISP decides to withdraw a service or to apply some filtering or to be used by a government to do something, then there is no option for the rest of the ISP. So really, we're looking at what is the diversity in terms of upstream connectivity. And then we're looking at, after we've looked at the diversity of physical and logical paths, we want to look at the network performance. So we're going to run active measurements here, including using the MIRA pods that we're deploying to run active measurements from people's homes to understand what is the quality of experience. And this is going to be in terms of web access, page load times, latency, and we're also going to talk about DNS measurements a bit later on. But all of that is going to be together looked at as the sort of access performance. What is the sort of performance that users experience? And we're also going to aggregate this data set and look at it together with other existing data sets. So for example, MLab has a lot of data where people have been running or are running their own speed tests from their browsers and so on. So we will look at that data set. Ookla also has some data set that we are going to look at. And then we're going to look at, within network performance, we're going to look at how traffic, how much of the local traffic is kept local within each country. So we're going to run some measurements, like looking at the most popular local content in each country. We're going to run active measurements to see whether we are able to access most of that content locally within that country, or somehow we're traversing international paths or inter-country paths or intercontinental paths to access content within each country. So that's going to be an important metric, and looking at how that affects or impacts the quality of experience for the users. And then we're also going to look at network and web interference. So we're going to look at whether there is any interference that exists either within ISPs or because of maybe government interference or whatever. But we're going to run some measurements also to understand whether some countries are more prone or more have this as a big problem. we're going to use some of the existing tools that are already doing a good job on this. So for example, the UNI probe, which is the Open Observatory of Network Interference. So we're going to adapt this tool and use it at country level to understand the level of interference. And then we are going to, in work package 4, we're going to do almost similar to what we've done in work package 4, but we're now going to focus more on the mobile internet access, because we know a lot of internet users in Africa access the internet via their mobile devices, maybe via mobile network providers. And we are going to focus on that quite a bit also. We're going to run a campaign or campaigns where we're going to run active measurements and collect data sets from mobile devices to understand the quality of experience. And again, we're going to link this with existing data sets to see if we can get a better understanding of what's happening. Similar with the other network providers, we're also going to look at how much of the traffic is kept local and whether there is network interference as well. Okay. And then DNS resilience. So this is, we find this to be a very critical, part of or component of the internet, and we have a work package that looks at specifically how resilient our DNS infrastructure is, again at country level. So we are looking at DNS reliability, and in particular, we're going to look at CCTLD's resilience. How well do they respond to queries, and in terms of the infrastructure, how resilient is it in terms of how it's deployed? Topologically, are the servers distributed in different networks? Are they distributed geographically or not? So this is something that we're going to try and map as well, and get metrics that we can use to quantify the DNS resilience in a country. And we're going to do also a study on DNSSEC adoption. And then currently another study that we are doing in terms of DNS is to measure the adoption as well as performance of secure DNS. So DNS over HTTPS, DNS over TLS, and trying to measure its performance in these different countries and in comparison with the sort of regular DNS. Okay, so for this, I just need to mention that we have a similar sort of a containerized measurement tool that we will be deploying on the MIRA probe. So a container that has all the scripts that we need to run the measurement, the DNS measurement scripts, automated, allowing us to run several measurements, custom-made measurements, and being able to collect all that data set and being available for our analysis. Okay, so this is something that we see already why it was a good thing to have something like the MIRA pods, because it allows us to create these measurements and deploy them quite flexibly. Right, and then we have, of course, the data pipeline. I'll let Kevin discuss more of this. So all of these data sets that that I've talked about is being collected and then being pipelined into our store and being processed there. So I'll let Kevin talk about this again a bit later on. Okay, and then we also have, apart from the active quantitative measurements that I've talked about and what we're doing, we would like to add on top of that, or look at this data in also in line with a qualitative data set. So we will be running, and we've been and we will continue to run sort of qualitative studies, running surveys and talking to people about their experience with the internet So some of the questions that we posed at the beginning of this this session was exactly that, trying to understand whether people experience downtime, whether people experience degraded service, whether they experience power outages, and how often that happens. And we want to capture that and use it as part of our resilience index for each country. Okay, so in a nutshell, this is what we're doing in the various work packages. I'm happy to discuss more of this in the Q&A, and we also have a more detailed write-up, a white paper that we wrote with the colleagues that we mentioned earlier on, and the links are available. You can read this in English, French, and Spanish. And happy to take questions. I think that will be a bit later on, but I have included also my contact details on this slide in case anyone wants to chat to me about some of this. Maybe especially in closing, let me also, if there are people that are participating here that are potential postgraduate students, most of the things that I've talked about here are potential projects for postgraduate students. Whether you are doing this in your country or you're traveling to another African country, we can always discuss and see how we can work with you on projects that support this MIRA project in the different work packages that we have described here. Thank you so much.
Thank you, Josiah. There's a request that you paste the links into the chat so that people can click on those links. Thank you. And just a note, if you do have questions, please do use the Q&A feature, which you'll see at the bottom of the screen. You can put your question in there and then we will answer it there. We have one more short presentation from Amreesh, and then we'll go into a question and answer session so that we can actually talk about some of these things. And then we will have another presentation and then another question and answer session to end the session with. So I will hand over to Amreesh, who is going to talk about Internet Resilience Index and indicators.
Thank you so much, Susannah. Hello, everyone. Good morning, good afternoon, and good evening. It's a pleasure for me to be here and talk about a very important aspect of the MIRA project, which is about building an index. Let me share my screen quickly. Okay, so yes, this talk is about building a composite indicator called the Internet Resilience Index. So let's start with defining what is the Internet Resilience Index. So the Internet Resilience Index is a composite indicator that measures a country's performance against the key pillars of what we would like to have a robust internet ecosystem, right? So first of all, why do we need an index? As my colleagues mentioned earlier, what people want at the end of the day is meaningful connectivity. Actually, this term has been coined by the Alliance for Affordable Internet, where basically we just need, people don't need to have just the internet. They need to have regular access to the internet where, they are not subjected to frequent disruptions, whether it is accidental or intentional. You might have heard many cases where either it is, accidental, like a cable break, or sometimes people in Africa, in some countries, for example, during election periods, where you have shutdowns, and this is a frequent sort of disruption. When you browse the internet, you would like to have a fast enough connection so that you do, whatever you like, for example, video streaming, or like today, watching an online webinar. So you would like to have a good enough connectivity. So right now we are saying that we would like a minimum of 4G as a mobile connection, or at least 10 Mbps as a fixed line over fiber, for example. But as you know, that's not currently the case in many parts of Africa. People are still struggling to have a bare minimum of 2 Mbps, for example. Unlimited connectivity is something important, because having a data cap, for example, would limit the amount of time you spend online and the potential that you can actually get from accessing either educational material or work-related stuff. And finally, people need an appropriate device. Without, for example, if you have a basic feature phone, you cannot do much, but having an appropriate device is important. So we need an index to actually measure at least 2 of those or 3 of these aspects here: having regular access, a fast internet connection, and unlimited connectivity. And as I mentioned, we have different types of challenges, whether it is disruptions or networks not being provisioned enough, or lack of redundancy. In some cases, taking the example of the undersea cables, a country like Seychelles, they have only one undersea cable connecting the country. So what if a ship break that cable? So that country might face some issues with their internet connectivity. And one important aspect of resilience is access to electricity. As you know, many countries in Africa, access to power is still a huge challenge. My friends from South Africa will tell you about the load shedding that has been happening for a couple of years now, and how this can actually become quite of a headache. So for us to be able to build an index, so the index eventually will allow us to rate a country, we first need to establish a theoretical framework. And in that theoretical framework that we built, we define 4 pillars, 11 dimensions and 30 indicators. Well, first of all, before building an index, we need to check whether there is already an existing one. So we have seen a lot of indices, for example, the Mobile Connectivity Index, the Global Cybersecurity Index from the ITU, but there's not one which is focusing on the core aspects of the internet, as all of the I would say the building blocks of the internet that Josiah mentioned earlier. So we came up with 4 pillars. The first one being infrastructure, in which we have 3 dimensions: the cable ecosystem, mobile connectivity, and enabling infrastructure such as data centers and IXPs. Performance, of course, we would like to investigate what is the performance in different countries. And based on the performance, when we talk about performance, it is both for fixed and mobile networks. And here we are looking into things such as upload, download speed, and latency. And we know for a fact that even if you have a high capacity link, if you have high latency to the services you wish to use, it doesn't make any difference. So having both speed and latency is very important when evaluating that indicator. We have also a pillar about enabling technologies. Enabling technologies, you can think about, for example, IPv6, HTTPS, and some other technologies, TLS 1.3, for example. You have a very important aspect of the internet, which is the DNS ecosystem. Without the DNS, you will have a lot of trouble navigating yourself through the internet. So the DNS ecosystem is very complex. So we need a couple of indicators for the DNS ecosystem to be able to have a good understanding of what's happening. The routing hygiene, equally important as well. how good or how bad routing is in a country, or people following the best practices, so on and so forth, and security threat, which incorporates things such as the amount of address space in a country, which we have seen spam coming out, or the DDoS potential, like what is the risk that one country is posing to other neighboring countries, because these countries are not following the best practices in terms of securing the networks. And finally, there is not a resilient internet if the market itself is not resilient. If, for example, you have such a market structure which is very skewed, so where, as my colleague Josiah mentioned, if there is only one operator dominating the scene, it makes the system very, very brittle and very easy to break, actually. Another aspect is traffic localization. People would like to have their content as close as possible to them, so that we reduce the costs both in terms of latency and quality of experience, but the cost of also using international bandwidth to reach faraway servers to actually watch local content. So the first step before identifying the pillars and the dimension and as well as the indicators is to do the data selection. So how did we proceed to do the data selection? Of course, there are multiple indicators, literally hundreds of them that we can choose. But the idea, the aim here is actually to build a robust index that can, withstand the test of time. We want that index to be still relevant in let's say 5 years or 10 years. So of course we use well-established criteria, for example, from the EU GRC or from the OECD, that these are organizations that are very well acquainted with building indices and composite indicators. We wanted as much as possible to rely on hard indicators, which means that data which are being empirically measured and through, proven methodologies that can be reproduced as well. So we didn't want to rely too much on qualitative data, for example, surveys, because then it would mean that we will have to rerun the surveys. And as you know, when you run the surveys, there's a fair amount of bias that is actually included. And finally, this index, the Internet Resilience Index, makes use of already existing index. You could, for example, the e-government development index is a very good indicator of the maturity of the e-government services in a country, and e-government services can be considered, for example, as local content. So I would say four main criteria: relevance. The indicator should actually contribute to say that whether there is an increase or a decrease in resilience. It should be accurate, as I mentioned. It should have good coverage. So that indicator should cover at least 75 countries. So if there are, let's say, more than 25% of countries missing for that indicator, we would not take that indicator. And timeliness, as I mentioned, we should have indicators that are frequent and also frequently updated and quite fresh with the data that are being collected. For example, we cannot take indicators from, let's say, 10 years ago and incorporate it in our model right now, because the data would not be up to date. So we start with the first pillar, which is infrastructure. And as I mentioned, we have 3 dimensions: cable ecosystem, mobile connectivity, and enabling infrastructure. And for the cable ecosystem, one thing we will be looking into is, for example, the number of international gateways. So we mentioned about what if a country a cable is cut, so they should be able to reroute traffic that was using other routes, for example, using inland routes or satellite connectivity, for example. The ITU is providing a very interesting data set called the 10-kilometer fiber reach, so which is basically saying what is the percentage of the world population close enough to the fiber. So this having more population close to the fiber increases the chance that people can get good connectivity. And I mentioned about power availability, which is a very important aspect. For the mobile connectivity, we are going to look into coverage. So what is the percentage of people being covered by, let's say, 2G, 3G, 4G, and now we are even talking 5G. So these indicators are coming from the GSMA, which we know are people that have been doing quite a lot of research in this area. For the enabling infrastructure, we are getting data from the packet clearinghouse and peering DB, where basically we can get the number of IXPs in a country, and we can see over time whether this number has been increasing. And the number of data centers as well is an important indicator. For performance, I mentioned about we are going to look into both fixed and mobile networks, and this data is coming from Ookla. So Ookla has something called Ookla for Good, where they basically open source all their data sets, of course at a aggregated level, but enough to have granular data about different geographic points in a country. And yeah, so we are going to use Ookla data, which obviously, you know, this is a crowdsourced platform with more than 10,000 servers, almost covering all countries in the world, and you know, millions of tests every day. For the enabling tech and security, talked about IPv6 adoption by country, the HTTPS adoption, like we would look at the top 1,000 websites in a country and see whether they are using HTTPS. For DNS, at the moment, we are going to look at validation. So how much at a country level, how much DNS validation is being used. We will look at whether the CCTLDs have adopted DNSSEC, so basically all the CCTLDs signed. For routing, we are going to use Manners. So Manners has developed a quite an interesting set of metrics which incorporates, for example, is an ASN doing proper filtering? Is a network doing proper coordination with other peers? What is the status with global validation? Whether it is for IR and RPKI, and we are using that Manners score as an aggregated indicator to actually rate the routing hygiene in the country. Talked about the security threat, which is so Welbeck provides some information. For example, the number of secure internet servers per 1 million inhabitants. The Global Cybersecurity Index has recently been released by the ITU. It is a composite indicator itself, which has many different components and gives a very good indication at a country level of the cybersecurity scene. DDoS potential and spam infection are actually also interesting metrics that provide good country level indication of the, I would say, the security threat that a country poses to other countries in the world. And finally, we talk about the market structure, affordability, having a good internet connection which doesn't break is good, but if it's not affordable for us, it's not resilient. Market concentration, as I mentioned, a high market concentration towards a small set of networks makes the whole ecosystem very brittle. and does it show, you know, equality or equity between the different providers of the internet? The more decentralized the market is, the more robust it is usually. And finally, traffic localization is also, as I mentioned, an important pillar in which we will look into, for example, peering efficiency. What is the number of ASNs peering in a country? And things such as domain count, popular local content, and e-government development index are all important indicators for this pillar. So once we have all these data, so I mentioned that we have 30 indicators. What is the next step? So first of all, we selected data. We selected the indicators where one, we need to make sure that they are readily available, and they will be available in the future as well. But we need to make sure that they are also covering 75% of all the countries. Otherwise, we'll have gaps in the data, and we will not be able to provide a very good final index. So first of all, we need to see whether there are any missing data. So the first step is to run data imputation. So any missing data, we need to see whether we can impute the data. There are a range of techniques, for example, regression, substitution, interpolation, or extrapolation that we can use to impute the data. The next step is winsorization and transformation. So some data can be skewed. So sometimes because of bias, sometimes because of outliers. So we need to make sure the data are within specified ranges. Otherwise, it will skew also the final index. And finally, you have, as you have seen, each indicator is based on a metric with their own unit of measurement. For example, the number of IXPs cannot be compared directly, let's say, to affordability, for example, or to, let's say, the number of domains under ACCTLD. So we need to normalize the data. We need to bring everything, for example, actually between 0 and 100. Zero meaning like this is the lowest score, and 100 being the highest score. And once we normalize the data, then we can move to the next step, which is assigning weights and aggregating to find the final index. So in terms of weighting as well, there are different techniques from the literature. For example, you could look at the statistical relationship between the indicators. You can run, for example, something called the principal component analysis, which basically gives the correlation between the different indicators, and based on that, you can assign weights or compensate on other indicators. But the way we decided to proceed is actually with a qualitative approach. Basically, each member or each segment of the internet, they have a different views about resilience. A network operator would have a specific view of internet resilience. A policymaker would have a specific view of internet resilience. So the way we want to do it is to gather expert opinions, and based on that, we would assign weights. What you see on the screen are just indicative, and we'll eventually change based on the opinion that we are going to harness. And the final step is to aggregate the data, and here as well, there are, I would say, two main techniques. Either you add them, you multiply them by the weights, and then you add them, or you can also multiply the indicators to themselves. So this is also based on the type of the data, which is in the indicator. Whether the indicators are substitutable between themselves or not, then we would decide whether or not we would use an arithmetic aggregation or a geometric aggregation. And that would bring us to a final index, which is between 0 and 100. That would allow us to rate a country. But we do not want to focus only on the index. The idea at the end really is so that the end user can navigate between the dimensions and the indicators, because, for example, a network operator might be interested into the DNS resilience aspect. The indicator is just there. The final index is just there for us to be able, for example, to rank the countries. But the most important aspects would be really to dig into the data and see, for example, what are the challenges and how increasing, for example, let's say adoption of a technology can improve the overall index. So we have started to crunch a little bit of data, and we have started to collect data from, as I mentioned, on those different indicators. Unfortunately, we are not yet ready to show you the full picture of the index. It's still work in progress, but we have some data. For example, this one is, I think, is coming from the DDoS potential. As you can already see that, okay, the top one is not normalized, the second one is normalized. We use the min-max normalization technique, and we can already see some indication which other countries, you know, can be a victim of a DDoS or who is posing a threat, for example. That's it. So if you have questions, please do not hesitate to ask a question in the Q&A section. Thank you.
Thank you, Amreesh. We will move now into a quick Q&A session. There are some questions open in the Q&A function, but if anybody would like to ask a question in person, please raise your hand and I will enable your microphone for you to speak. Do you want to answer Jeff's question and Paul's question, Amreesh, in the Q&A?
So let me take Jeff's question. What do you mean relevance indicator showing an increase and decline in the resilience of the internet? Is it showing that the data of customer using the internet service in each selected country? It is monthly users or an annual user of data? What happens in a selected country? The internet data users. So when I meant relevance is that when I talk about relevance is we need to select a set of indicators that would actually contribute to the model that we are building of. There are many different indicators that we can select. For example, if you take the GSMA mobile connectivity index themselves, they have different indicators. But not all of the indicators that have helped build the mobile connectivity index is actually useful for the internet resilience index. So what I meant was that we should select indicators that are actually relevant to the model that we are building. So in our case, we focus on the core aspects of the internet, the core building blocks of the internet. I don't know, Josiah, if you want to add up on that. Okay.
And there is another question there from Paul and one from Tahir.
So from Paul, one could imagine a situation in which a country could score as highly resilient, but a larger percentage of the population lacks affordable access to mobile or fixed broadband connectivity. Have you considered adding something on the percentage of population with access to affordable broadband, both fixed or mobile and at home? Yeah, so that's a good point. And this is where I was talking about indicators being substitutable. So in some cases, you would have a high availability or high affordability, but then the quality of the network is bad. So is one compensating the other? So these are the things that we actually need to see, whether one indicator is compensating for the other. And based on that, this is where we will determine whether we are going to use one sort of aggregation or another sort of aggregation. So that's a very good point, actually, and we will incorporate that in our model. How can we participate in MIRA as individual? Can we participate as an individual? So maybe Kevin, you want to take that one?
Yeah, sure. Thanks, Amreesh. So I'll talk about that in my presentation, how you can participate. So if there are no other questions, maybe I could start presenting, and then that will be addressing the presentation as well.
Are there any other questions? If not, we will move on to Kevin's presentation. And don't forget, we do have another question and answer session at the end of the session. So you still have another chance to ask questions. Okay, go ahead, Kevin. Thank you.
Thank you. Thank you, Susannah. Hi, everyone again. So I will make a presentation about the active measurements. So Amreesh has talked about the Internet Resilience Index and some of the active, sorry, not the active, but some of the data sources that we're using to score a country in terms of how resilient it is. We want to complement those measurements with some active measurements that we are going to carry out. We have started carrying them out. We are using Raspberry Pi 4 devices for active measurements, and we are managing these devices using an IoT fleet management platform called Balena. If you go to balena.io, you'll see more about Balena. The Raspberry Pis run a measurement client called Murakami. It is a client that's been developed by MLab, and this client is able to carry out throughput tests and round-trip time tests. And the way the Raspberry Pis work is that inside the Raspberry Pi, it's basically running a Linux operating system, and then you can launch the Murakami client as a Docker container, and then it runs the active measurements to MLab infrastructure, and you can increase the number of MLab servers that you'd like the test to be carried out to. Now, an important point to note here is the Raspberry Pi does have a lot of spare resources. It is a 4 GB RAM Raspberry Pi, and we've noticed that there's a lot of idle space. So it is possible to run more Docker containers, and it's something that we're going to explore moving forward so that we can increase the number of measurements we're able to do. So right now we have roughly 24, 25 active probes. By active, it means they are on and doing something in terms of the measurements. Those are the countries. On the left column are the countries where the probes are at the moment. The number of active probes. There are more probes in some countries, but perhaps not connected yet. And then the final column you see here on the right is the ISP, which the probe is measuring. Now, the way we are doing the probes is they are just connected in someone's home network. So just in your home switch, or the router provided to you by your ISP, you just plug in the Raspberry Pi, and it has already been pre-configured, so you don't need to do any configuration. And as soon as you plug it in, it comes live on the Balena IoT management platform, and we're able to see it and start collecting the measurements from it. You probably see here that in Zimbabwe we've put a to be confirmed. I was hoping that it would be live today, but the device is still not plugged in. It's with my colleague called Berengai. So hopefully in the next, by tomorrow, by next week, there'll be more information about which ISPs we are going to be measuring from in Zimbabwe. So the two current tests, round-trip time and throughput. The tests are to 7 MLab servers. So let me quickly explain how the tests run. The Raspberry Pis run the client, but the client, of course, needs to connect to a server in order to run the test. So they run the test to the MLab server. They do the throughput test, basically how fast is the link, how much bandwidth can you push through the link. These are 6 tests per day, and the reason there are 6 tests is because we're trying to get a bit of variety of the data. So we don't want to just run the test when someone is at home and maybe the network is bogged down, but we want to run different times of the day so you can get the actual feel of what this internet connection, how that internet connection performs. Round trip time, again, very simple. It's a ping test with the result. How long does it take to get from the client to the MLab server? So we've been running this test for about 7 or 8 months now. And the way we've been doing this is, in order to aggregate all the data that's coming in, We have connected the MIRA devices or the Raspberry Pis. They send their data to a Google Cloud Server instance or GCS. Some of you may be familiar with GCS. And then using BigQuery, we're able to extract the data points that we want, which are at the moment throughput speed, latency, connection type, whether it's fiber, 4G or something else. Then we're also experimenting with visualization. Basically, how can we graph the data that we're seeing right now from the MIRA pods? And we are refining the process. We are not, GCS is not going to be the final platform we're going to use for visualization. We're going to use a platform on ISOC Pulse, which you can see at the end of this presentation. I'll provide a link to the ISOC Pulse dashboard, but that is the eventual plan of where the data will be. But we're using the GCS to refine how we collect the data and how we are going to visualize the data. So a simple structure of how the RPIs are connecting. So the RPIs send their data to, the RPIs carry out the measurements through MLab as I described. This data is sent to GCS cloud instance. Then using BigQuery, we're able to extract the data points that we want and graph them through Google Data Studio, sorry. So here is one result of how the data, the type of data that we are receiving from the Raspberry Pis. The data is in a simple JSON file that you see here. You will see that there's a metric here, there's a data field, Murakami network type, the speed, the ISP name, the country, and the timestamp when the actual measurement was carried out. So we have a variety of links right now. We have fiber links in some countries where there's fiber. In this particular country, which is Burkina Faso, the data type is, the connection type is actually a 4G connection. So even though we write here that it's a 15 Mbps link, you can see here from the download value and the upload value that the speeds are actually much, much higher. So this shows that perhaps, on 4G, maybe the speeds fluctuate up and down at different points in time. So these are some of the analysis and refining of the data that we are actively trying to do. So this dashboard here is what we're able to obtain from Google Data Studio. We can obtain different type of graph. We can graph, let's say if you want to see how are the measurements between country A and country B, we can get those type of measurements. We can see, for example, how fast was a measurement from, let's say, Nairobi, Kenya to Ouagadougou in Burkina Faso, or how fast was the connection between Mauritius and South Africa, at least for the countries which we have probes at the moment. We're still refining this dashboard, but we are able to get at least some interesting data. We're still analyzing it. This graph will show you another view that you get from Google Data Studio. And you can see, there are a lot of fields you can customize, a lot of data points you can turn on and turn off. So it's a continuous process for which we are, we're using the GCS to refine it. And then eventually this will end up on an ISOC dashboard or platform called Pulse. So some preliminary results from the data we've seen so far. We have 7 MLab servers. 2 of them were launched under the MIRA project, the one that's in Mauritius and the one that's in Burkina Faso. Local tests that we can see in terms of throughput tests, in terms of round trip time, we can see that when a test is done from an RPI in the country to an MLab server in the country, the results are very good. The round trip time is very low. So this indicates perhaps that there's a presence of an IXP that's doing quite well, functioning as it's supposed to function, and the ISPs in that country have connected to that IXP. And we are going to continue, as I mentioned, it's a continuous process to refine. So we're going to be able to extract more data points like that. So how many of those ISPs are appearing at the ISP? How many ASNs are present in that network? Why are there perhaps more ASNs assigned than we are seeing at the exchange point? Another preliminary result we've seen is that the throughput tests that when a link is provisioned, let's say if it's a fiber link, for example, in the countries that have fiber, if a link is provisioned at 10 Mbps, the throughput test is either 10 Mbps or very close. So that shows good performance within the country. But we have noticed that when it's a throughput test to an MLab server outside the country, the speeds are a bit lower. So as I mentioned, there's going to be a bit more analysis as to why that is the case. So as I mentioned, GCS is a temporary solution for now. We are going to be running our own infrastructure in terms of the aggregation of the data and the graphing, and this is what it's going to look like. So not a big change, just replacing some parts of how the data is aggregated and presented for view. So some feature measurements, the Raspberry Pis are running Linux OS, so it is possible to add other type of tests. These are the three that we've identified we can do, and we'll be piloting them soon, very soon. The first one there is file download tests from CDNs. So CDNs, the aim of a CDN is to take the data as close to the audience as possible. So we want to be able to include that as a metric. How well is a CDN performing in terms of providing data close to the audience in that country? So we are able to do like a download for a file, something from CDN. That's something we're going to experiment. We're going to do also DNS measurement tests. And as I mentioned, we are able to spin up more RIPE Atlas Docker containers, more Docker containers. And one we believe that we'll be able to launch is a RIPE Atlas container so that we can also perform RIPE tests on the same Raspberry Pi. So that sort of is one reason why I think there was a question earlier, why are we going with our own measurement infrastructure, so that we can be a bit more flexible in terms of the measurements that we want to carry out. So a few questions in the chat, how we can get the probes. Right now, we are primarily assigning them through our ISOC chapters. If you'd like to host a probe, please get in touch with your local ISOC chapter. We were hoping to be a bit more aggressive with the outreach for the probes, but this project was put in place in 2019. We were hoping for a more aggressive approach, but we've sort of toned that down and we're working through our chapters for now. And we're still doing some development of how communication between the probe and the host of the probe will be done. So on the right here is an image of a test that one of our consultants is working on, which will be a Telegram bot to communicate with the owner of the probe to tell him, for example, the probe is offline or just come back online, so that you can, be aware of what your probe is actually doing. So some interesting tests that we're hoping to do in the near future. So a few next steps, the work that Amreesh presented, completing that Internet Resilience Index, we want to finish that in this quarter. We are increasing our probe outreach, as I've presented, or as mentioned. We are working on visualizing the work that Amreesh is doing, and also complementing that with the active measurements that I've just spoken about in MIRA. And then we want to do more periodic calls like this, more periodic updates to the community. We're going to be doing that to the measurement working group that's hosted by AFRINIC. I'm going to provide a link at the end of the call. And then we are looking at expanding partnerships with organizations who may be interested in the measurements we're doing, who are interested in the type of research you can do with the reports that we're going to be generating from the project. I've mentioned a lot the Murakami client, which has been developed with the support of MLab. It's an MLab client, but we did request them to add a few more features to allow us to carry out our measurements. And I'd like to introduce Chris from MLab, who's going to be talking more about MLab and the Murakami client. So Chris, over to you.
Super, thank you, Kevin. I need just a moment. It looks like I've been signed out, this Google sign in, sign out piece that happens periodically. So bear with me just a moment. While I'm getting there, I will say that, Kevin, you covered a lot of ground, and my role today is much like our work together. Supporting your research has been a highlight for me this past year. So it's great to be supporting the work of AFRINIC and ISOC in this regard. Let me share my screen. And we'll just get going. And I think that I can also reduce some of the time I had planned to present. So we have a little bit more time for Q&A. So I will do that and then present. So thank you all for attending and for the invitation, Kevin and Amreesh, Josiah, and others. I'm Chris Ritzo from the Measurement Lab project, and my title is Program Management Community Lead, which basically means that I do some prototyping research and research projects coordination, as well as a lead person on our community involvement. So gaining and providing access to our tools and our platform and our data at MLab for researchers and advocates. So a quick bit about Measurement Lab. We are a joint initiative with Cover Science, Google, and other contributing partners. Our purpose is to provide an open repository of longitudinal internet infrastructure measurements that are open data from open source tests, and to manage that infrastructure to support and aid the creation of that data repository. We were founded in 2008 to address the question of how to measure at scale different aspects of the internet. And we achieve this by hosting different measurement tools and experiments and tests and providing that data. Our core team is at Code for Science and Society, a nonprofit organization based in Portland, Oregon, and these are our staff here. And then we also have a set of core contributors at Google who contribute both internet research, infrastructure support, and some software engineering that makes the collection of measurements and publication of them happen through our platform and pipeline. So to address some of the questions that came up in the chat, what are MLab's infrastructure? What does that look like? And what are the measurement services and data that we have? So if you're interested in learning more about where we are in the world, our infrastructure status page, the link here, provides a great deal of data about each location where we host servers. All of our measurement locations are off-net, meaning they're in tier 1 data centers or in internet exchanges where our last mile networks peer. So we're measuring to the middle mile, essentially, of the internet from locations where people initiate tests. Each location is a hard metal location with 4 servers and a high capacity switch to a single transit service provider. And in larger metro areas of the world, we strive to add multiple pods or sites connected to a diversity of transit hosts. Kevin mentioned locations in Africa where we host servers, which are on this map, but I'll also touch on some of the work that they're doing to host their own servers with the open source NDT server. As mentioned, our tests or measurement services are listed at measurementlab.net/tests. All required to be open source and are reviewed and approved by an experiment review committee. We also host core services that select or that capture detailed statistics for TSP connections. Currently, in the future, we hope to add other types of connections to those core services, but also trace routes back to the originating IP addresses that connected to our servers. As mentioned, we are off net, so contrasting with other popular platforms like Ookla, which are primarily on net, servers or tests to our servers inherit that topology, measuring beyond the last mile network. And of course, if there are researchers on the call or tool developers who wish to host new measurement experiments or tests, our platform does support that, and any open source test can be proposed. The 3 primary tests we have on the platform currently: NDT, which Kevin mentioned, Dash, which is a emulated video streaming player testing, maintained by Simone Basso, and then WeHe is the most recent test to be added to the platform, which measures the differential treatment of applications by ISP, maintained by the team at Dave Toffney's team at Northeastern University. One quick slide to just emphasize the difference between Ookla, let's say, and as the most popular test that Kevin and Amreesh have mentioned, and MLab's tests. So the measurement of the local access network and the total link capacity versus the end-to-end capacity, or the baseline measurement of TCP, which is what NDT would measure to the middle mile off-net server. And it's important to note that those data sets are different, and this audience knows that, but I must mention that. So our test will measure the impacts of interconnections between the local providers and their upstream providers. So to the question of why Murakami and what is Murakami, as many of you are likely familiar with MLab as a crowdsourced data platform. Our large data set for NDT, for example, is